said that both of these are in slope-intercept form, right? So what that means is that both these terms are written like this, where we have y is equal to m times x plus b. And we said that m was the slope, which graphically is the rise over run, the up and the over. So the rise can go up or down depending on if the value is positive or negative, and the run can go left to right depending on if it's positive or negative, right? Does that make sense? And then we said the b term is what we call the y-intercept, and that's where it crosses the y-axis. And so I want you guys to write this down on your worksheet. There's plenty of room for everything else. Write it down real small over there to the side like I did. And it's a reminder, because if you just keep looking at it, you kind of forget about it. I want you to write it down because I want you to think about it, okay? Because this is not going to go away. It's on the SAT. If you, when you go to college, they're going to go over all this stuff again in your college level math class. So this is kind of a big deal. Now, if I were to graph these, it would look something sort of like this. So if I were to graph this equation, it would cross at 1, 2, 3, 4, and it would have a negative slope where I go down 5 over 2, and it would kind of cross like that. Now that's that first equation. The second equation, if I graph that, it's going to cross the x-axis, or I'm sorry, the y-axis at 1, 2, negative 3, and it has a positive slope. So somewhere where the two cross is the solution for these two equations, where they have what we call a common, in other words, they're going to share the exact same xy. Okay? Now here's the thing, I have two equations that are set equal to y. For example, I have negative 5 over 2 plus 4 is equal to y. Then I also have x minus 3 that's also equal to y. Now if they're both equal to y and they have the same y, guess what? They're equal to each other. So I could say negative 5 over 2x, there's an x there, I don't know why I forgot to write it, plus 4 is equal to x minus 3. Now one of the challenges we face with this particular problem is the fraction. Nobody likes fractions. Does anybody remember how we got rid of the fraction last time?
Oh, did you have to multiply or divide?
Yeah, we had to multiply everything by the denominator, which is 2. So I'm going to multiply every one of these terms by 2. So I'm going to say 2 times negative 5 over 2 times x plus 2 times 4 is equal to 2 times x plus 2 times negative 3. So I'm multiplying every term by 2. Okay? Now at some point in time you won't have to write out as many steps. I want you to write it out now so you can visually see which mathematical operations we're doing. Okay? Now for this one, the first one, I've got 2, which is the same as 2 over 1. These 2's cancel and I get negative 5x plus, what's 2 times 4?
So 8.
8. Whoops. Got a little carried away there. So that's 8 is equal to, what's 2 times x?
2x.
2x. And then positive 2 times negative 3 is what?
6.
Negative 6. Right? Alright, cool. We got rid of the fractions. Now we got to solve for x. Now remember that when we're trying to solve an equation, we want x by itself.
Wouldn't you just put like those two together?
I'm trying to, hold on now, I'm trying to explain something to you. I want you to pay attention. Don't get ahead of me. We want x to be by itself and all the other stuff on the other side. Now I realize here we have like just numbers, so the stuff is just numbers, but in upper level math, later in this year for you guys and next year too, you'll start solving variables. In other words, you'll have x all by itself on one side and maybe other letters on the other. Okay? And the way that we do that is we do opposite or inverse operations.
Where'd that 2 come from?
What 2?
2 outside the fence.
This one here?
Yeah.
Well, I didn't like the fraction, so I got rid of it. Now, one way to get rid of the fraction is because what does that really mean? It means I'm dividing by 2 on just that term. So to get rid of that fraction, the inverse operation of division is multiply. So I want to multiply that first term, this term right here, by 2 so I can cancel them. But remember, because it's an equation, whatever I do to one term, I have to do to the other thing, especially with multiplication and division. If it's adding, subtracting, I add on one side, I add on the other. If I subtract on one side, I subtract on the other. But with multiplication, I have to do it by every term. Same with division. Okay? Does that make sense? So I just picked 2 to get rid of 2. If this would have had a 3, I would have multiplied everything by 3. If this would have had a smiley face, I would have multiplied everything by a smiley face, just because I don't like fractions. Does that make sense?
Yeah.
Okay. And that's a legal move. We could do that as long as we do it across the equation. So now, I want to get x by itself. The easiest way to do this is to add 5x on this side, because I don't want a negative x. See, if I were to move the 2x on the other side, then I'd end up with a negative 7x. I don't want to do that. But if I add 5x to both sides, these x's cancel. I'm left with a positive 8 here is equal to 2x plus 5, which is a positive 7x minus 6. Does that make sense? And this is a negative, this is a minus sign. Now, I want to get everything away from the x, so what do I move next?
6.
And how do it's technically a negative 6, so how do I move a negative 6?
So you add 6.
Yeah, so since I'm subtracting 6, I'm going to add 6. And whatever I do on one side of the equal sign, I got to do to the other. So I get 14 is equal to 7x. Is x by itself?
No.
No. What's in front of the x?
7.
7. What does that mean, 7x?
You're timesing 7 by x.
You're timesing. What's the inverse operation of timesing or multiplication?
Divide.
Divide. So what do I got to do?
Divide by 7.
Now we're only dividing by 7 because I want the x to be by itself when I'm done. So 7 divided by 7 is just 1. 1 times x is x. What's 14 divided by 7? 2. All right, we're done. That was a lot of work. Right?
Yeah.
Are we done though?
No.
Why not?
You have to plug in 2 to one of the equations.
We need a common x, comma, y. And right now I only have an x. So I'm going to pick the second equation because it's shorter and easier and doesn't have a fraction. So now if I take that equation and I want to find y, I'm going to say y is equal to x minus 3. But what x value am I going to plug in?
2.
2. So what's 2 minus 3?
-1.
Negative 1. So my solution should be x comma y or 2 comma negative 1. Okay? Does that make sense to you guys? Now, I can verify this and double check it. How do I do that?
Plugging it in.
We just graph it. So what I want you guys to do now is turn on your calculators. Yes?
So when you said that we couldn't, you said we can put the -7, you get what I'm saying?
Yeah, mathematically it'd work out the same. You'd end up with a
Yeah.
negative 7x equals negative 14, and then when you divide by negative 7.
Yeah, because that's what I did and I got the same answer.
Yeah,
So
it will be the same, yeah. I just like to try to make it easier sometimes. So now what I want you guys to do is when you turn on the on button, you'll get this screen, right? What do we want to use our cursors to scroll down to? Graph. So we're going to go down here. If you go down to the graph here. So use the cursors to highlight this little thing that looks like a graph, then hit enter. And then I'm going to plug in the first equation, which is -5 divided by 2 times x plus 2. Or no, plus 4, sorry. Then I hit enter.
The line.
Boom, there's our line. Now, does anybody remember how we add the second equation?
Just click on like the top of the grid.
If you go to the center of the cursor and you double click on it, oops, you got to make sure that your cursor's on the screen somewhere. Then it'll ask for a second function. So my second function is just going to be x minus 3. Okay? Now, where should these two lines cross?
At,
2.
and
Hey, guys, we're looking for the solution. It should be 2 comma
3.
negative 1. This is our solution right here. Where does it cross? 2 comma negative 1. Now, how can I find out for sure? If you go to menu, first of all, raise your hand or hold your calculators up so I can see that you've graphed both lines.
How do you, hold on, the second one's not open. You just double
You gotta, I'll show you this. Look at my screen. You've got to be somewhere where, like if you go down here and you try to click on it, it'll do something different. You got to be somewhere where there isn't stuff going on. Then you just double click on this. Okay?
What was that, x minus 3?
X minus 3. It's on your worksheet. Yep. Now, if I want to find, the calculator can calculate where the two lines cross. So what you do is you hit menu. You scroll down to analyze graph. You guys remember that? And then you go down to option number 4, which is intersection. And you want to move the cursor. It says lower bound. See how it says lower bound right here? You just want to move the cursor till it's a little bit less, lower meaning less than where the two intersect. And then you could click the center thing. And then it'll say right bound, and you use the cursors to go a little bit above where the two cross. And then it'll print off the intersection for you, which is what we calculated by hand, right? 2 comma negative 1. Now the reason that's the solution to both of these equations is because that's where they share the same x and y. In other words, when x equals positive 2 and y equals negative 1, that satisfies or makes both equations equal.